Welcome to Talking Melons for 2020, a series of presentations that brings you a range of topics to assist in growing and marketing Australian melons. The presentations are available on the Melons Australia website as a video, a podcast, and as a slide deck. Visit www.melonsaustralia.org.au.
Hi, my name is Singh. I'm a food safety scientist with the New South Wales Department of Prime Industries. And I'm also the project leader of Melon Food Safety R&D project funded by Hot Innovation, using melon growers R&D levy and the contributions from Australian government. I'm going to present a webinar on packhouse environmental control and management. This webinar is offered as an information service by the New South Wales Department of Prime Industries and Hot Innovation. To read the full disclaimer statement, please refer to the presentation slides. In our Safe Melons program, we have provided melon packers and growers a number of food safety resources, and one of those resources is a puzzle on melon food safety. In this melon food safety puzzle, which is aimed to ensure the safe supply of melons to consumers, packhouse hygiene and sanitation is one component. In today's webinar, I'm going to talk about packhouse environmental management control and strategies to manage environmental pathogens. So the objective of packhouse environmental management program is to verify sanitation effectiveness through detection and prevention of environmental pathogens harbored in a packing house. So an environmental pathogen can survive and persist in the packing and grading equipment or holding environment and cause cross-contamination. So there are two major environmental pathogens that have been of concern to the industry. The first one is Listeria monocytogenes, and the second one is Salmonella species. So what are the sources and routes of contamination in a pre-harvest environment? If you look at the slide, it shows that melon production is carried out in open fields, which are surrounded by wildlife, livestock, or other livestock and poultry operations around the property. So these pathogens can come from these domestic as well as wildlife excreta. So there are several routes of contamination of the melon fields, and the major sources are through irrigation water, soil amendments in the form of organic fertilizers, and sometimes the weather events such as dust storms, flooding, causing runoff can also introduce these environmental pathogens in your melon fields. It's very important to understand the potential vectors and routes of transfer of these pathogens into the field and from the field into the packing house. So on this slide, you will note that we have shown the major sources of environmental pathogens such as the wildlife, soil amendments, and agricultural water. They all can introduce these environmental pathogens into your melon fields. From the melon field, when the fruit is harvested, so the fruit is one of the major sources of environmental pathogens that can be potentially brought into the packing shed. There are other routes as well, such as machinery and equipment, harvest bins, and trailers. They can also bring these environmental pathogens into the packing house. So it's very important to understand various factors which can predispose your melon farm as well as the packing shed to various environmental pathogens. So the Packhouse Environmental Management Program that we call PEMP is based on 5 pillars. The first pillar is the packhouse layout and design, and the second is post-harvest processing flow, and the third pillar is the equipment design, and the fourth one is cleaning and sanitization, and the fifth one is environmental monitoring. In today's webinar, I'm going to go through all these pillars supporting the Packhouse Environmental Management Program. To start with packhouse layout and design, on the slide you can see the design and layout of an ideal pack house. In an ideal pack house, we expect that the pack house should be fully enclosed and there should be distinct separation between various zones of fruit processing, and the product as well as the workers' traffic flow should be one way. In this slide, you will note that on the left-hand side, which is the fruit receiving and washing area, there should be a pre-cooling facility where fruit can be pre-cooled before it is washed and sanitized. And after washing and sanitization process, there should be a physical boundary to mark the movement of fruit into the grading and packing zone. And then after grading and packing, the fruit moves into cool room and storage area. So it is recommended that handling and storage area should have positive air pressure, and the positive air pressure will help the pathogens in terms of the transfer through airflow away from the area where the processed fruit is handled. In the melon industry, there are packing houses which are ideal in layout as well as design, but there are some other packing houses which are semi-enclosed packing houses. In the semi-enclosed packing houses, there is washing and sanitization step which is carried out in semi-enclosed area where it's partially exposed to the external environment, and then the fruit enters into grading and packing zone. So we identify that some of these semi-enclosed pack houses, they are at medium risk in terms of environmental pathogen risk in these facilities. However, there are also a number of packing houses which are quite old, and they are open pack houses where there's no distinct zones and most areas are exposed to the external environment. These pack houses are considered at high risk in terms of the exposure to the entry as well as establishment of environmental pathogen in the facility. In each pack house, to implement an effective pack house environmental management program, we need to identify various zones in the pack house. Zone 1 is the fruit contact surfaces. For example, brushes, conveyor belts, packing tables, which often come in contact with the fruit. Zone 2 is near fruit contact surfaces. So for example, these surfaces are very close to the fruit contact surfaces. For example, the underside of conveyor belts, hollow rollers, and the inside assembly of some of the drying tunnels and even washing areas. Zone 3 refers to non-fruit contact surfaces, that the surfaces which do not come in contact with the fruit directly. For example, floors, walls, and forklifts, etc. Are major non-fruit contact surfaces. Zone 4 is the outside pack house area, for example, loading docks and workers' facilities and lunchrooms, etc. Each melon packer should identify these zones clearly because it helps them to segregate raw as well as processed fruit handling areas, and to help manage them workers as well as machinery's traffic flow in the facility. I'm going to talk a bit about the potential sites in a packing house where these environmental pathogens can establish and form biofilms and then act as a continuous source of cross-contamination. So in Zone 1, fruit contact surfaces, as I mentioned before, conveyor belts are one of the major hotspots for cross-contamination where pathogens can form biofilms and establish. The other surfaces include brushes, hollow conveyor rollers, grading and sorting cups, packing tables, curtains in drying tunnels. So the identification of fruit contact surfaces in your packing shed is critical in terms of developing and implementing a proper cleaning and sanitization schedule. Other areas where these environmental pathogens can harbor are near fruit contact surfaces. These surfaces, they are not in direct contact with the fruit, but if the pathogen grows on these surfaces, they can potentially get transferred to the fruit contact surfaces. These surfaces include conveyor belts, undersides, hollow rollers. If there is a crack in these rollers, or if the end caps are wearing out, so the pathogen can grow inside and then move towards the fruit contact surface. And electrical cords, metal cracks, and bolts and threads, these are some of the other near fruit contact surfaces. In packing sheds, there are several other non-fruit contact surfaces which can support the growth as well as survival of these environmental pathogens. These are floors, drains, and plastic curtain strips in the cool rooms, and entrance and exit roll doors, cool room floors and walls, fruit waste areas, and hand wash stations. So each packer should identify these non-fruit contact surfaces which can get contaminated and potentially transfer pathogen to your fruit. The second pillar of post-harvest environmental management program is the post-harvest processing flow. So there are three major components in this. The first one is product flow, and the second one is workers traffic, and the third one is machinery traffic. The pack house layout and design should be such that it should be one-way traffic in the facility. So to mitigate the risk associated with the spread of pathogen from one area to another, it's very important to separate raw and finished product areas. If possible, there should be physical demarcation. Otherwise, there are some other ways to enclose those areas and mark them properly so that there's no mixing of raw and finished product in your packing facility. The second recommendation is to have dedicated equipment, container, and machinery in different zones. For example, a forklift which is used for unloading the harvested fruit in the receival area should not go into the cool room. So a forklift should be dedicated for outdoor and indoor use. Thirdly, there should be minimum crossing of the forklifts and employees from the wet to dry areas in the facility. So these are some of the ways to manage the traffic of workers and machinery in the processing facility, but it should be undertaken very carefully as the spread of pathogen from dirtier area to clean areas can lead to major issues of contamination in the facility. The third component in Packhouse environmental management program is the equipment design. The best equipment design is the one which is simple and easy to clean and dismantle. However, the existing infrastructure in Melon packing sheds, there are several issues with the equipment design which are not friendly from food safety perspective. So if you are setting up a new facility or even doing upgrades to your existing facility, please do consider that the equipment design should be such that it should be easy to dismantle, clean, and sanitize. So in the equipment, there should not be any sharp edges, absorbent areas, and cushioning. Some packing sheds, they use a lot of cushioning material in their packing line to minimize the physical damage to fruit at various points in the facility. So these cushioning material can be quite congenial for the growth and multiplication of environmental pathogens. So we recommend that packers should consider their equipment design as well as the material that is used in their conveyor belts, their hollow rollers, which are used as conveyor belts. So in the slide, you can see that some of the packing tables with absorbent material, which can potentially harbor these pathogens. And then you can also see some of those rubber mats being used in a packing line to prevent the physical damage to the fruit. So these kind of fittings in the packing line are ideal environments for these pathogens to grow and multiply. And they are very hard to reach, where pathogen can easily survive your cleaning and sanitization schedule if you are following it. There are some more pictures in the next slide where you can see some of the mesh screens in the packing line, and a picture down there with in a drying tunnel. You can see they are very hard to clean inside because they cannot be disassembled regularly. On the right hand side is a conveyor belt, which is interlaced with some metal pieces. So these are the spots which become a source of contamination when the pathogens form biofilms and they sit underneath. The fourth pillar in the packhouse management is cleaning and sanitization. I would like to bring into attention of packers that cleaning and sanitizing are two distinct processes to achieve pathogen control in packhouse environments. While cleaning is the physical removal of soil, debris, and food particles, and even some microorganisms using detergents under recommended conditions. So a surface must be cleaned before it is sanitized. Sanitizing, on the other hand, is the chemical treatment to reduce the number of microorganisms using a range of sanitizers with appropriate concentrations and contact time. So packers should carefully consider that sanitation is though a generic word, but it has two underlying processes, which are cleaning and sanitization. So sanitization cannot be achieved on an unclean surface. In our Melon food safety resources, we have developed a fact sheet on packhouse cleaning and sanitizing, which explains various steps in undertaking cleaning and sanitization in your packhouses. But all packers should have a cleaning and sanitization schedule, which should define frequency and measure to validate the effectiveness of cleaning and sanitization program in the packing shed. So we recommend that cleaning crew should be trained, and the same person should be, or the team members should not be changed frequently. We also understand that cleaning and sanitization is labor intensive and requires serious investment, but in order to ensure that your packhouse remains clean and free from these pathogens, cleaning and sanitization is the fundamental process that you should undertake to minimize those risks. So in a cleaning and sanitization schedule, we often get a lot of questions around how frequently. As a thumb rule, it should be a daily cleaning schedule for fruit contact surfaces, such as harvest bins, dump tanks, wash tanks, brushes, rollers, conveyors, fungicide tanks, and packing tables. There are some non-fruit contact surfaces, for example, drains and floors in fruit tipping, washing, and packing areas, which should be cleaned and sanitized at the end of each shift. Other workers' facilities, such as hand washing station and hygiene facilities, including foot mats, they should be cleaned and sanitized on a daily basis. There are other non-fruit contact surfaces which can be cleaned and sanitized on less than daily basis. Depending on the size of the operation, it could be either weekly or monthly basis. So some of these non-fruit contact surfaces which can be cleaned and sanitized on less than daily basis include cool room floors and walls away from packing area, refrigeration units and drip pans, and so on. The last pillar in the Packhouse environmental management program is environmental monitoring. So why we should monitor the environment in the packhouse? The primary objective of environmental monitoring is to prevent the transient pathogens from becoming entrenched, forming biofilms and spreading from one part of the packing facility to the another part. And we would also like to verify the effectiveness of control measures which are in place for cleaning and sanitization of the equipment and facilities. And the third objective is to detect these pathogens before they spread, and also to determine and undertaking corrective actions. So in environmental monitoring program, we should focus on seek and destroy approach. I call it seek and destroy bugs before they bug your business. So in seek and destroy approach, we develop a environmental monitoring program in which we are focusing on the microbiological testing of environmental pathogens. So we received several questions from the melon growers and packers around what should be the target pathogens in the microbiological testing, where and how to sample, how frequently, and where they should get their microbiological testing done. As I mentioned before, in the seek and destroy approach, you should be aiming to look for two major target pathogens. One is Listeria monocytogenes, and the other one is Salmonella species. Sometime it is recommended that you go for microbiological testing of Listeria species. So because some of the Listeria species are non-pathogenic to humans, so they act as a very good indicator of the presence of Listeria monocytogenes in the facility, as Listeria species testing is quicker and more economical, but it can provide a good indication of the packhouse hygiene and sanitation program. So Listeria monocytogenes is a major environmental pathogen that has caused several issues recently to major horticulture industries. This pathogen can survive under wet and cold conditions. On the other hand, Salmonella species, they can also survive under very harsh conditions, which could be dry and warm. So we recommend that the growers and packers, they should target these two major environmental pathogens in their environmental monitoring program. In order to answer how frequently should you go for testing of the environmental samples, I would say one size doesn't fit all. So it depends on the produce volume as well as the packhouse risk history. It's a general guidance that large operations which are processing approximately more than 20 tons per shift should go for a weekly testing of their environmental samples, and those who are processing in between 3 to 20 tons per shift should go for a fortnightly environmental testing schedule, and small pack houses which process up to 3 tons per shift, they can follow a monthly schedule. However, the frequency of testing can be varied depending upon the requirements in the facility. If there's positive detection or if there's a weather event such as dust storm or flooding, we recommend that you increase the frequency of testing and the number of samples that you test for the presence or detection of these environmental pathogens. Another question in seek and destroy approach is how many samples. So it's also a very subjective question, and so the number of samples that should be collected from a pack house again depends on the volume of the produce being processed and the scale of the processing facility. And the established melon businesses, they also have data from the previous seasons and years. So it's always a good idea to do the trend analysis and the history of the detection of these environmental pathogens. So we recommend that at least 5 to 7 swabs from each zone of the processing facility should be collected as part of the environmental monitoring program. However, you can also increase the number of swabs depending upon the length of your packing line and the complexities of your packing and grading equipment. We also recommend that you go for at least 5 processed fruit samples as endpoint testing to verify that fruit washing, sanitization, as well as your environmental monitoring programs are effective. The next question is when to sample. So we recommend that environmental samples should be collected at 3 stages. The first stage is that the environmental samples should be collected after pack house sanitation, but prior to production. If you find environmental pathogen test is positive at this stage, that means your cleaning and sanitization is not effective, and potentially an environmental pathogen is residing in your facility, which is not affected by your cleaning and sanitization program. The second time is to collect the samples when the processing has been going on, so which is generally performed after the equipment has been running with fruit for 2 to 4 hours, which is also helpful to even pick some of the transient pathogens going through the facility. The third stage is when you should be collecting samples is after cleaning the pack house, but before sanitization. This strategy is also helpful to determine if there are any transient pathogens in the facility, and also to get an idea on your sanitization program's effectiveness. So how to collect and transport samples? We recommend that the packers should contact their microbiological testing laboratory for detailed instructions on how to collect samples. However, we recommend that the staff should be trained in understanding the aseptic principles to follow the sampling schedule. Generally, we recommend that sponge swabs should be used for larger areas. However, Q-tip swabs can be used for hard to reach areas where sponges cannot reach. So it's important to label the samples properly. We recommend that you should avoid compositing for targeted harborage identification. If you swab a large surface area or too many equipment with the same swab, if that swab is tested positive later on, you will not be able to identify the exact location of the pathogens establishment. So we recommend that in the early stages of the environmental monitoring program, your sample number and the sites of your sample collection should be high compared to as you progress with your monitoring program, you can reduce them slightly. After collection of these samples, they should be transported to the laboratory with frozen gel ice packs so that these samples are maintained at 0 to 4 degrees Celsius, and the sample should be tested by an accredited lab in your state or territory. So what happens if you receive a positive detection of an environmental pathogen such as Listeria or Salmonella? So we have prepared a decision-making chart, which is also present in the Melon food safety resources and toolbox to help the packers in their decision-making. So in case the positive detection is from fruit contact surfaces such as conveyor belts, packing tables, or brushes, we recommend that you stop processing your fruit and undertake cleaning and sanitization of the equipment and area, and also implement test and release strategy, which means the fruit which were processed on that particular day, they should be destroyed and or recalled if they're already in the trade. So until you receive 3 consecutive negative tests from the facility, you should be interrupting your processing and going for deep clean in your fruit contact surface areas. If you receive a positive detection from non-fruit contact surface, the food safety team should be vigilant, but there's no need to stop the processing. But you can clean and sanitize the equipment and area where the detection was found, and the swabbing and testing should be repeated until you find negative results. What happens if you find a positive detection during the end product testing? So, for example, if there's a positive detection of Listeria monocytogenes on a processed fruit sample, packers should be able to differentiate between transient pathogen versus resident pathogen by consecutive sampling and testing schedule. So what is a transient pathogen? So transient pathogen is one which randomly comes with the fruit from the field, but it doesn't get established in the facility, and it moves on. However, the resident pathogen can cause serious issues because such pathogens can form biofilms in your facilities. For example, you can see in this diagram on the right hand side, the fruit contact surface contaminated with Listeria monocytogenes can act as a source of cross-contamination and can cause a large-scale contamination of the fruit. So we recommend that packers take advice from experts in differentiating these transient versus resident pathogens in their facilities. New South Wales DPI and Hod Innovation, we have developed Melon food safety resources, which are available on DPI's website. Alternatively, you can also Google New South Wales DPI Melon Food Safety Guide and Toolbox. These resources are developed for melon growers and packers to understand and manage the risk. And there's a lot of information about packhouse environmental control and management strategies in these resources. One of the fact sheets that you will note in these resources is on Packhouse Environmental Monitoring Program, where we have listed the steps and strategies aimed to prevent and establishment the entry as well as establishment of the pathogen in a pack house. If you have any further questions or queries regarding the development of cleaning and sanitization schedules in your facility, or developing an environmental monitoring program, you can feel free to contact me as part of our food safety help desk service. So in this project, we have been offering melon growers and packers technical advice to help them develop such plans and implement environmental monitoring programs so that they don't allow these pesky pathogens to establish in their facilities and give them trouble. So I would like to acknowledge that this webinar was part of a Melon Food Safety R&D project, which is in the second phase and is funded by Melon Growers R&D Levy and matching funds from Australian government. And I'm also thankful to Australian Melon Association for giving this opportunity to record webinar and share my experience with melon packers through the channel. Thank you very much.